Greetings and welcome to the week 3, unit 4 on cognitive processes, evaluate and create. In the earlier unit, we understood the cognitive process, apply and analyze of revised Bloom's taxonomy. So the next two processes are evaluate and create. So in this unit, we'll attempt to understand the cognitive process, evaluate and create of revised Bloom's taxonomy. Now coming to evaluate, it is formally defined. We may be using the word evaluate in a day-to-day language to mean slightly different things. But in the context of Bloom's taxonomy, evaluate has specific meaning. Make judgments based on criteria and standards. Okay, you are making a judgment on something that is given to you. And the criteria can be either qualitative, the criteria can be related to the quality, effectiveness, efficiency, or consistency in the context of engineering. The standards may be either quantitative or qualitative. So in that kind of context, people have to make judgments. And in this also, we have two sub-processes. One is checking, the second one is critiquing. Again, they have very specific meaning. Checking is judgment about consistency. We'll elaborate. Critiquing is judgment based on criteria and standards. One is about consistency, the other is about criteria and standards. And the action verbs that we use for checking is test, detect, monitor, coordinate, and so on. Critiquing, we will use the word mainly judge, but you are judging either accuracy, adequacy, appropriateness, clarity, cohesiveness, completeness, correctness, reasonableness, reliability, validity, etc. Okay. So whatever thing that you are judging from any of these will come under the category of critiquing. Now let us look at checking. Check means to test for internal consistency or the logic or accuracy of a process, a product, a system, or an argument. Any of these we are checking the internal consistency to identify flaws, errors, or contradictions. That is what checking means. In engineering context, this typically refers to activities like debugging, troubleshooting, testing, and validating system or results to ensure they meet specified criteria. Debugging and troubleshooting and testing software modules is a very common thing in computer science related subjects, and that activity really belongs to the level of evaluate. Now some sample activities we can see. Check if energy balance is close in a Rankine cycle simulation using mass and energy conservation laws. Check for overloading, short circuits, or incorrect ratings in an electrical panel layout. Test the correctness and efficiency of an algorithm using test cases and edge inputs. Check a software modules through unit testing and code review to find logical or functional errors. These are some sample activities that we are likely to come across in engineering areas. Now coming to critic, the next sub-process in evaluate cognitive level, critic means to detect inconsistencies or fallacies within a product or reasoning, or to judge a product or performance based on internal evidence or external criteria. The critic sub-process involves judging based on criteria and standards. That's what you need to remember. In engineering, this typically means assessing the strengths and weaknesses of a design, solution, a method, a report, or argument, often using explicit standards such as codes, efficiency, safety, or cost effectiveness. Because these are the engineering quantities against which we make judgments, or we need to make judgments. Now, critic involves judgment, not just logic checking like in check, often based on qualitative and quantitative standards. Requires reasoned argument and evidence-based evaluation. What it means, you cannot just merely say, I feel this is not adequate. You cannot make such a statement. So you have to have a reasoned argument for make such a conclusion, or you must be able to produce some evidence for that, for your judgment. It includes identifying bias, assumptions, and alternate perspectives. Okay. Now some sample activities of critic. Critic a bridge design proposal based on load factors, material choice, and environmental sustainability. That is, a design proposal is put in front of you. Your critiquing means you are checking whether, or rather you are making sure the proposal is satisfactory based on load factors, material choice, and environmental sustainability. Judge a building's electrical layout for safety, compliance, and energy efficiency. Judge the design of a healthcare unit in terms of usability, comfort, reliability, and patient safety. Judge the design of a web application for accessibility, usability, and responsiveness. So these are some sample activities that come under the category of critic. Once again, in some of the engineering disciplines or branches, these activities presently are not really included. That is, the curriculum doesn't provide for taking the student to perform this kind of activities as a part of any course. And when you don't, when it is not included, you are not really addressing the very important cognitive level, namely evaluate. Now come to the sixth cognitive level of revised Bloom's taxonomy, which is create. Create means, or it involves, putting elements together to form a coherent or a functional whole. It looks very unattractive. So you're putting elements together to create some. You're creating something from different elements and creating a whole. You're producing a whole. It includes outcomes that call for unique production as well as outcomes indicating productions that students can and will do. So you have to give an experience of creating something to the students. And here again there are three sub-processes. First one is generate, second one is plan, third is produce. Again, a student should experience all the three stages of create. Generate, we can call it as a divergent phase, in the sense that we want, if one produces multiple or alternate solutions to a problem, then you call it, you are in the generate phase of create. It is a divergent. Once again, we do not seem to give this kind of experience to the students. Very rarely we ask students to, let's say, either as a group or as an individual, to produce three solutions to a given problem. Which is better, that comes later. But first, are you capable of producing three solutions, correct solutions to a given problem? Okay, that is the divergent phase. Next one is plan, which is the beginning of convergent phase. Then what you do, out of alternate solutions that you have, use some criteria to select the what you think is the correct one, and you have to produce or you have to devise a plan for solving the problem. That means you have to, let's say you want to produce, you want to design a chair, take a simple thing like that. Then what do I have to do? I produce a lot of alternatives in the beginning, and then depending on finally, because you use different materials, different shapes, uh, different functionalities into that, and having decided on all that, you select one out of the whole thing, and then you work out how do you have to create a plan how to produce that. You have to produce some drawings and specify the materials to be used, what kind of material to be used, and so on. And that is creating a plan. Then the third phase is actually produce. That is, either you create a based on the plan that you have generated, you actually construct the product or fabricate the product. As a student, you would do that in the workshop or in the laboratory. Now, the action verbs for this: generate, develop alternate hypotheses, theories, and explanations. All this is generate. Then plan, the words are plan and design. So kindly note that design is a permitted or acceptable action verb for the create process. But just because you have used design as a verb, it doesn't become automatically create process. What is implied in that, you have to make sure. That is what we explained in the case of apply. Then produce, we can use the word construct, fabricate, and so on. Coming to generate. A generate subprocess involves formulating alternative hypotheses, ideas, or plans. It focuses on divergent thinking, encouraging students to propose multiple possible solutions or conceptual designs before selecting a refining one. This is what we consider a very important phase of engineering education, which unfortunately, because of the mechanisms that are operative, we never get a chance to introduce the students to this generative phase or divergent phase of producing alternate solutions and then selecting one from that. So some sample activities of generate. Given the task of designing a low-cost cooling system for rural areas, generate multiple design concepts using alternative materials, energy sources, and thermodynamic principles. Faced with the problem of power loss, in transmission, generate multiple solutions. For an urban drainage issue, generate multiple layout options for stormwater management to handle peak runoff. Given a software requirement for a mobile health app, generate multiple architectural approaches and justify their potential. So, as you can see, the focus in all these activities is to generate multiple solutions to the same problem. Now, coming to the plan sub-process involves devising systematic method, procedure or plan of action for executing a solution or design. So, word design also means, a dictionary meaning is creating a plan. You are not actually producing the prototype or the product. You are creating, you are making a drawing, or you are making a, let's say, plan to make something. It includes structuring ideas, setting goals, choosing tools, and organizing steps in logical and effective sequence. That will be what do you call, all the steps involved in presenting a design to somebody. Some sample activities of plan. After identifying the most viable site for a bridge, plan the construction schedule, including stages of excavation, foundation, superstructure erection, safety checks, and environmental management. That means at the beginning of this activity, what do you call, you have already decided a particular type of bridge is to be built at in a given site. That solution is finalized, but the design is not. Now, in this phase, you are actually producing a plan, but this plan also is only for some of the activities here, as in this example. Given a software specification for a smart home controller, plan the development process, including module breakdown, timeline using agile methodology, risk management, and deployment strategy. After deciding to produce bioethanol from a selected feedstock, plan the end-to-end process, including pre-processing, fermentation, separation, waste handling, and process control. These are some 3 sample activities of plan. Now the third sub-process is produce. The produce sub-process refers to the actual implementation, putting a plan into action to build or develop a final product, system or solution. This stage transforms ideas and plans into tangible or testable results. Some sample activities of produce. After planning a sustainable pavement system, produce a scaled model or segment of the roadway applying selected materials and construction techniques. After system design and coding, produce a fully functional mobile application for real-time public transport tracking, integrating front-end and back-end components. Produce a wireless sensor network prototype, incorporating microcontrollers, RF modules, and sensors for environmental data collection and transmission. So once again, to repeat, because this is a issue that often comes when we design our class tests and end semester exam, design exercises that we typically use in engineering courses are applications of well-defined procedures and thus are at apply level rather than at create level. Just because you use the design as the action verb, it doesn't automatically become a create process. Okay, you should remember that. And also it is difficult to have activities that can be completed in a fixed time session. That is, you give half an hour, 20 minutes and say you design something. So it is not possible to create something for that. But that create experience will have to be given elsewhere, not through what do you call finite time examinations, like end semester exam of 3 hours or class test of 1 hour to 1.5 hours. So these create exercises can be given through assignments, mini projects or major projects. They have a you are likely to get the required time to do something under that. Okay. So in the next session, W3U5, having seen all the 6 cognitive levels, we'll try to understand the scope and limitation of cognitive levels of revised Bloom's taxonomy. And thank you for your attention.